Let's have a look at this exercise together. Simple sample establishing the confidence interval on the proportion or estimating a proportion. So this is an example on automobile engine crankshaft bearing. So in a random sample of 85, so we have 85 crankshaft bearings, 10 of them have a surface finishing that is rougher than the specifications allowed. Okay. So we have the total sample size n equals to 85. And how many of them are exceeding the specifications? That is 10. So the proportion, okay, the point estimate, what's the point estimate of the proportion of bearings in the population exceeds the roughness specification. So the p hat will equals to x over n, that will be 10 over 85. So this is approximately 0.12. So that's the first problem. And second problem is, what is the 95% confidence interval on the proportion of bearings in the population exceeds the roughness specifications? Okay, so based on the discussion in the class, we know that the confidence interval equation that is on the population P, that is less than P hat plus Z alpha over 2. So this is 95%, so alpha over 2 will be 0.025. Yes. And the standard deviation will be P hat 1 minus P hat over n, and then greater than P hat minus Z 0.025 P hat, and then we have 1 minus P hat over n square root. Okay. So we know the P hat is 0.12 and Z 0.025 is 1.96. So P is less than 0.12 plus 1.96 times 0.12 times 0.80, that is, should be 88, divided by n, how many? 85. 10 of them exceeded the specification. So this is 0.12 minus 1.96 square root 0.12 times 0.88 divided by 85. So P should be less than 0.19, greater than 0.05. So this is the 95% confidence interval on the proportion of bearings in the population exceed the roughness specifications. So the third question, how large is the sample required if we want the 95% confident? We want to be 95% confident that the margin of error is less than 0.05. Okay, so what is the margin of error? Margin of error is actually Z alpha over 2 times square root P hat 1 minus P hat divided by n. So this is margin of error. We want it to be less than 0.05. So n should increase. That it equals to 0.05. Then we increase the sample size. Okay. Now let's derive n. N will equals to Z alpha over 2, Z 0.025 divided by 0.05, right? and then square p hat, then 1 minus p hat. So this will equals to 1.96 square over 0.05 square times 0.12 times 0.88. So this is approximately 163. So if you wanted the margin of error to be smaller, so you increase the sample size. So n should be greater than or equal to 163. Now, if we want to be at least 95% confident that the margin of error is less than 0.05, regardless of the value of p, okay, what will be the sample size? So, you know, p hat 1 minus p hat. And if we reaches the maximum when p equals to 1/2, right? So then this part will become p1 minus p will equals to 1/4. Okay. So this function will reach the maximum. So that is p minus p squared. So if you have a f p equals to this, if you do the f partial derivation, it will be 1 minus 2p, set it to 0. So this function will reach the maximum when p equals to 1/2. So that's a reason. Now, if we regardless of p, so in the margin of error, if regardless of p, so we just make sure, so this n should equals to z alpha over 2 over the margin of error, and then square, right? And then this is a p 1 minus p. So because this will reach the maximum when p equals to 1/2, so we directly just put 1/2 over here. And then we put z alpha over 2, 1.96 over 0.05 square times 1/4. So this will equals to 385. So if your sample size reaches 385, because you are increasing this n to 385. So regardless of the p-value, the proportion, the true population proportion, and you are confident that the margin of error is less than 0.05. That means the sample size is bigger than you estimate the proportion is more accurate. So if you have information concerning the value of p, either from the preliminary sample or from the past experience, we can use a smaller sample. But if not, you can use a large sample, okay, to make sure the margin of error is smaller than a particular value. So in this case, it's 0.05. So this concludes our exercise on estimating the proportion and establish the confidence interval for the proportion too.